Okay, this is number 8B on lesson 7.3. Here's the problem. It's on page 391 in your books. The solid lies between planes perpendicular to the x-axis at x equal negative pi thirds and x equal pi thirds. The cross sections perpendicular to the x-axis are, for part B, squares whose bases run from the curve y equal tangent of x to the curve y equals secant of x. So let's graph those two curves first. So we're going to go to y equals, graph tangent of x, and secant of x. Secant is 1 over what? 1 over cosine, so 1 divided by cosine of x. And we could hit zoom trig, which is zoom 7. Kind of get an idea of what we're talking about. And we get the tangent graph and the secant graph. But they say we only need to look between x equal negative pi thirds and x equal pi thirds. So let's set our window x min of negative pi divided by 3 to positive pi divided by 3. And let's hit graph and see what that looks like. X scale, I'm going to do pi divided by 6, I think. It doesn't really probably matter. There's my tangent graph. There's my secant graph. So we're looking at that region that's between there. Okay? So let's make a sketch of that first. So my tangent, and I'm going from, again, negative pi thirds to pi thirds. So the tangent graph kind of goes like this. Something like that. And the secant graph kind of goes like that. Okay. And so we're looking at this region right in here. Right there. Okay? So that's our region. Again, this is y equals secant of x. This is y equal tangent of x. And then it says we have square cross sections. So you have to imagine that we have, let me show you real quick with a piece of paper here. We have squares coming out of the board at you. Different size squares. For example, this square might sit right here, coming out of the board at you right there. Okay? Down here, if I can get my paper to fold, there'll be smaller squares coming out of the board like that. So there's bigger squares here coming out, whatever this distance is, they come out that far off the board. Down here there'll be little squares. Okay? So you get something like this. Now these squares are too small, but something like this with squares coming out of the board at you. Alright, so we know that our formula, the general formula you want to use when you do a problem like this, is the volume is equal to the integral, and then you have to have your cross-sectional area here, which in this case is a square, and then times either dx or dy. Now, if these squares are coming out toward this direction, like this, then the skinny dimension of these rectangles, the skinny direction of these squares is running sideways, right? It's running this way. So if it's running sideways, is that a change in x or a change in y? That's a change in x. So we're going to use a dx right here. Which means all of these, this equation has to be in terms of x. And our bounds have to also be x's. So what do you think our bounds are going to be? Negative pi thirds to pi thirds, right? We're going to be slicing it up. You're going to have these cross-sectional areas running all the way from negative pi thirds to pi thirds. Now, these squares, to find how long the base of the square is, which would be from here to here, right? The base would be the part that it's sitting on. What would I do with these two equations? Subtract. How would I subtract them? What curve minus what curve?
Top curve minus bottom.
Top curve minus bottom curve. Yep. Now, why not do bottom minus top? Let me try to give you an example of that. Let's say that Brian comes up here and he's this tall. And I come up here and I'm this tall. If you do the top number, Brian, how tall are you?
Like maybe 6 foot.
6 foot, so that's 72 inches. I'm 68 inches. So if you do top curve minus bottom curve, that gives you that distance. There's a 4-inch difference between us, right? If you did bottom curve minus top curve, 68 minus 72, that'd be negative 4 inches. So we don't want to do bottom minus top. We want to do top minus bottom so we get a positive dimension, right? When you do geometry, usually you talk about that as a positive dimension. So by doing top minus bottom, you find that difference. Kind of like here, 72 minus 68 tells you that Brian is 4 inches taller than me. Okay, so that's an example of why you're doing top minus bottom. Okay, so the base, B, is going to be secant of x minus tangent of x. That's what gets plugged in right here. But let's go a little bit further here. Redo this here. What is the area of a square? If this is B, what's the area of it? Yeah, B times B, right? It's both the same, it's a square, so B times B would be B squared. So that means, whoops, smaller number always goes on the bottom, bigger number on top. Okay, our base is secant of x minus tangent of x and then squared. Now, some people are going to have a hard time getting that typed in correctly. What I would suggest, if you try typing it in and you don't think you're correct or you're not sure you're correct, is to go through and write it out. This is really what I'm looking for on the test, is this plus the answer. But to assist you in getting it typed in, it might be helpful to put what you're going to write on your calculator, which is going to be numerical integral. It's what's going to pop up on your calculator when you push Math 9, parenthesis. Then you're going to have to do secant, which is 1 divided by the cosine of x. The calculator is going to make you put those parentheses in there. Minus tangent of x. The calculator is going to make you put those parentheses in there. And then we're going to enclose all of that squared. And then you're going to have comma x, comma negative pi thirds, comma pi thirds. If you find yourself getting a negative answer, there's two things that could be happening. You could have these two numbers switched. If you put the bigger number first and the smaller number second, that'll give you the opposite. Or it could mean that these two things are switched. It could mean that you did bottom minus top instead of top minus bottom. That could happen. Okay? In this case, that may not make a difference. But if you end up getting a negative answer, those are two things to look for. All right, let's try typing it in and see what we get. So, second quit. Math 9. Now I'm just going to, I see two parentheses, so I wrote it out so I know how many parentheses to write in. 1 divided by cosine of x. Minus tangent of x. Another parenthesis, squared, comma x, comma negative pi thirds, comma pi thirds. 4.8338.
That's true. Yeah, it's square. Where's the square?
Got a question about something up here?
Yeah, it's
Okay.
squares.
Now we're finding volume, and we don't know if it's meters or inches or whatever, so I'm going to put units here. So what else do I put besides just units? Units cubed, right, because it's volume. It's volume, we're talking about cubic units. Go out at least 3 decimal places. The other thing to think of is sometimes people on a test will go, oh, I forgot pi. They'll throw pi on the answer. Don't put pi on the answer here because there's nothing that's circular here. Remember pi was derived because it's the distance around any circle divided by the diameter of a circle. That gives you pi. If I took this garbage can, measured the distance around it, divided by the distance across it, I'm going to get 3.14159, whatever. Okay? Do the same thing in this circle. If I take the distance around it divided by the diameter, that's pi. Okay? So if there's nothing to do with a circle, then you should not have any pi in your answer. So which methods would you use that might have a pi in them? Disk method, washer method. Disks and washers are round, right? Or then the semicircle method. There's a method where you use semicircles. Anything that's circular, you're either going to have to put a pi in your answer or multiply by pi. But if it's a square or a triangle or a rectangle, then you would not need a pi in your answer. Any questions about any of that?